we went through a very simple theory of beginning with the idea that we watch a bird in flight. There are two efforts, one on the vertical, which I called W1. So that's, or WY if you want, vertical. The other effort in a horizontal direction, W2, or WX, this way. They add up, meaning the animal suffers for two reasons. And what's the name of the suffering for the animal? It's hunger, because most of the effort that the animal does is the effort of looking and finding food, okay? Pay attention. Really, pay attention. Birds around where you live are constantly on the ground or wherever scrounging for anything edible, anything. Just watch very, very carefully what they do. And obviously they thrive that way. So the prediction that follows, obviously, from this idea that what has freedom to change changes in the direction of greater access. In the particular setup here, the freedom to change is the relative magnitude of these two efforts. You probably saw, if you remember, that relative size also means rhythm, frequent or not so frequent. So there is 1 degree of freedom in the notes that you took last time. You have a copy of that appendix from one of my books. The appendix has basically the written down version of that analysis. So there isn't much to the theory except the implications of its results. Anyway, so at the trade-off, meaning here, the speed, meaning order of magnitude, speed of how this animal should be moving, begins with a factor lowercase r, and then gravitational acceleration to power 1/2, the density of the body to minus 1/6, and then the body mass in kilograms to 1/6. This leading factor is shorthand for the ratio of two densities, where rho sub m is the density of the medium, all of it to power 1/3. And related to this, there are two other results. One is for the frequency, which you can get yourselves from these formulas. They have to do with the free fall a la Galilei. And that's in your notes. And at the trade-off, meaning when these two efforts are of the same order of magnitude, it means that the sum of the two is of the same order as either the first or the second. From that, you get the minimal effort, which is W total, divided by travel length. This would be minimal, corresponding to the optimal here. And that turns out to be 1/r, and then the body weight. This r, we talked about it quite a bit, distinguishes between the media in which the movement is occurring. Relevant to what I'm going to do next are the values of 1/r, which go with the effort. In air, this is 1/10. In water is 1. And then on land is somewhere in between, say 0.4, with variations having to do with the fact that the surface of land is not necessarily dry, is not necessarily flat. There's vegetation. There is all sorts of there are many complications that differentiate between, say, climbing through the bushes to the top of the hill, as opposed to walking sideways and sideways in a serpentine on a man-made path. Get it? Now you see a problem, don't you? Meaning a conundrum. Why do people and animals climb the mountain serpentine fashion? Because to go through the thicket is a lot more difficult than to walk longer but easier, you see. All right, so now connected with this bit of analysis is the much better idea, which is to express these results not in terms of body mass, but in terms of the length scale of the body. So if, anyway, this so-called animal has only one length scale, which is the mass or the length scale, and m is the same as the body density times the length scale to power 3. So replacing m this way, you discover that the optimal speed is proportional. It is related to the Galilean speed of free fall. This way r, and then gl to power 1/2. The formulas I'm writing on the blackboard will be useful in what follows next. So the bigger will be faster, is in this way similar to something that falls, again, Tower of Pisa, pebbles being dropped, something that falls from somewhere higher. I'm talking about the speed with which the falling object hits the ground is greater when it had been falling from higher altitude. All right? At this stage, because obviously I'm going through what I wrote last night, they call it intermezzo in Italian, a brief intermission. Galileo Galilei, he was experimenting with falling objects. He is credited with having invented the scientific method, which is that of testing predictions with measurements or with experiments. So the formula that he figured out for these falling pebbles was V, meaning while hitting the ground, after falling to a depth L, is, I wrote it before, square root of 2GL. Saying again that the speed of hitting the ground is greater when the object that hits comes from a greater altitude. And he tested this thing. How? He had nothing, really, no instruments. By the way, he did invent instruments. He invented, for example, the telescope, but that was for drawing what he saw on the moon. Yeah, what about that? So, of course, I ask you because actually I know I read the history of this great thinker. He saw something much simpler that was showing the free fall in the garden. In the garden, there was a water spout dripping droplets. Obviously, if you look at the lip of that nozzle, the droplets are exiting at the same time interval. You can even hear it. But it was pretty obvious that the droplets were accelerating as they were falling. And what I drew, Galileo Galilei drew, but he drew exactly from the observation. How did he know? The exact image that now you can imagine. Here's the answer. He had an iPhone. He just photographed it. How did he do it? I don't think I told this in the previous class. No, I didn't. It's a good thing Elsie is not a fake Christian. Yeah.
Could he have taken a piece of paper or something, right when as they were dropping, just move it across, so there'd be a dot in each part on the paper if he did it fast enough?
No, he didn't do that because, first of all, paper was not that plentiful, and this man, I don't know how agile he was in his time. He lived under great pressure. He was supposed to be burnt at the stake because he believed in, not believed, he was convinced that the earth rotates around the sun, not the other way around, and on and on and on, okay? Any of you have been to Rome? Yeah, his contemporary Giordano Bruno, another thinker, was burned at the stake. There's a piazza called, forget the first word, Dei Fiori. Maybe it is that, anyway, or flowers. They have a peasant market. It's right in the middle of Rome, around the statue dedicated to him. So in this case, the opposition of the church, opposition to the geocentric view was vicious. How did he figure this thing out? To draw it. I gave you a hint. He photographed it, okay? And he did it this way. He took two boards. You've seen them almost like 2x4s. And he put one here. And then here's one. And then a second one here. And then he clapped them together, and then he saw the wet spots between them, and these wet spots were obviously becoming more and more distant, lower, measured those distances and figured out that the formula was correct. In other words, he recorded in this way visually for the skeptics the fact that these objects that fall accelerate downward. So when you hear about F equals ma, which by the way that was written by Euler, not by Newton, you see that the idea of accelerating was already in play. I told you about Da Vinci and these other folks of that period. All right, so with that in mind, with this behind us, what is new today? New today is the challenge. It's like the little piece of sand in your shoe. It always bothers you, or something stuck between your teeth. You cannot get rid of it, So there's this thing. Listen, Adrian, turns out that there's great agreement between these predictions and all measurements of animal locomotion, flyers, runners, and swimmers. And they have to do with the fact that all these things that move are performing effort, except the fish. The fish are not fighting gravity because, I told you last time, everybody knows, and I told you, when you hear the expression everybody knows, you should Well, I was looking at, don't reach for a weapon just to walk away. You should question that. Quote unquote. Everybody knows that gravity doesn't matter to the fish.